Good morning, students. In this video, and to have our last math class before spring break, I'm going to actually just go through stuff we've learned over the last couple of weeks. It's been a very new learning environment, and you guys have done a really nice job. But rather than start a new lesson, I think it'd be wise for us to slow down and to go over all the concepts we've learned in the last 2 or 3 weeks. So you don't have any homework to do with this, but I do ask that you follow along. Make sure that if there's anything on here that you had forgotten or that you don't quite understand, reach out to me today before we go on break so that I can try to explain it to you. This is going to go all the way back to chapter 12, where we start by looking at angles on a point, angles on a line, and vertical angles. Remember, if we have a line, and let's say going off of that line's broken up into a couple different angles. These angles together have to equal 180 degrees because they're one side of a line. A complete circle is 360 degrees, so half of it has to be 180. Doesn't matter if it's an acute angle, doesn't matter if it's obtuse, doesn't matter if there's 3 angles or 4 or 5 or 6. Whatever it is, the sum of all of these has to be 180. So that's angles on a line. Very similarly, if I have a single point and I've got lines coming off of that, it doesn't matter how many lines. It doesn't matter if they're raised, doesn't matter if they are line segments. All of the angles coming off of a point have to add up to be 360. So at this point, I don't know anything about the individual angles other than the fact that they would add up to be 360 degrees. This is also one that I'm going to use to show vertical angles. Remember, vertical angles are angles that are on the opposite side of 2 lines that are equal to each other. Are all of these vertical angles? No, they're not, because some of these are just raised. It needs to be 2 complete lines going all the way through. So let's look at this. I'll get a different color and try and identify a few different pairs of vertical angles. This is a line and that's a line. So those are equal to each other. This one's a line and this one's a line. You can use a different color to identify those. And actually the only other pair of vertical angles has a ray going through the middle of it. So this larger one is equal to this larger one. Not just one of those, which has been split by a ray. But the angles that are opposite each other on lines are equal, which is going to be useful for us to know. Alright, that was a brief look at chapter 12. Let's move on to 13, identifying different triangles by their sides. This triangle has sides that are all completely equal to each other. So what do we call that one? That is an equilateral triangle. All sides are equal to each other. Equal. This one we've got 2 sides that are equal to each other, so what is that? That is isosceles, with at least 2 sides. We could actually consider an equilateral triangle to be a form of isosceles because it also has 2 equal sides. But it's more specific because it has up to 3. Isosceles just has 2. And what do we call the one where they're all different? That is a scalene triangle. What about identifying triangles by their angles? This one is a right angle, so what kind of triangle is this? It is a right triangle. This one has all acute angles, so what do we call that one? That's acute. And all obtuse angles would make this, sorry, not all obtuse, 1 obtuse and 2 acute, because notice that all of these have at least 2 acute angles. It's that third angle that makes a difference for us, so acute and obtuse. Also, it's worth noting that you can use both of these to identify triangles. So this one we can see is actually also right. So this is a right isosceles triangle. This is an acute scalene triangle. This is obtuse scalene. This looks like it's acute scalene too, maybe isosceles, and this is probably scalene right. So you can use one of these titles and the others to really identify something. This I'm just writing down as a fact that we've learned. The sum of angles in a triangle is always 180 degrees. I could get this protractor out, pick it up, and measure each of these angles, and I would find that yes, all of them when I add up the angles are 180 degrees. It can't be any larger than that. All right, the last couple of things we've looked over in the last days are special angle rules for special triangles. This is a right triangle. I know that all of these add up to be 180 degrees. This is a right triangle, which means that's 90 degrees. In a right triangle, the other two angles have to be 90 degrees. I would add them together and get 90 degrees, no matter what their individual sizes are. This one is isosceles. So what do I know about that one? I know that the angles on opposite sides of these equal sides are going to be equal to each other. And this one is an equilateral triangle. So what do I know about that? It's equilateral. I know that all three angles are the same size. So whether this was a tiny equilateral triangle, whether it's massive, the relationship or ratio between them is the same. Each angle is 60 degrees. That was a 2-day lesson we just crammed into a minute. So if you followed along with that, that is awesome. And the last thing we're going to look at is what we learned just yesterday. Inequalities of triangle sides. I can measure the sides of all of these angles and I'll find there is no single side that is longer than the sum of the other two. And the way I really do like to think about that is look at this one that doesn't quite work. If I lay the longest side down, and the two shorter sides try and reach, they fall down and they're not going to be able to meet each other. They're not long enough. Where these, as these sides fall down, they hit together at this point, which makes it a triangle. So the sum of the two shorter sides has to be shorter or smaller than that longest side. So what about these numbers that I've chosen here? 4, 5, and 8. Would that make a triangle? Well, 4 plus 5 is 9. And 9 is bigger than 8. And that's the biggest test. I can also check 5 plus 8 equals 13, which is bigger than 4. And 4 plus 8 is 12, which is bigger than 5. Yes, this one is all good. Now let's check this one. 8 plus 21 equals 29, which is bigger than 11. 11 plus 21 equals 32, which is certainly bigger than 8. And 8 plus 11 is 19, which is not as big as 21. So this one does not work because one of the sides is too long. And if you've reached a point where you just see this one and you start with this step down here, comparing 21 to 19, and you see that doesn't work, you don't have to go any further. You know already it does not work as a triangle. All right, so 5th grade, that was a 8.5-minute summary of 3 weeks of work. So if you have any questions, please be sure to reach out. But otherwise, we'll start to look at 4-sided shapes after spring break. Enjoy your Easter.